everybody, this is lesson 21, slope and average rate of change. This is a little bit of review for middle school and a little bit of new stuff for Algebra 1. So as you go through probably each problem, especially in the review, until you get to the average rate of change part, you can probably pause the video and see if you can do it on your own. On a sheet of notebook paper, do you know rate of change, slope, undefined slope, zero slope, and average rate of change? Figure out the words you know and the words you don't know. Rate of change is a rate that describes one quantity, how it changes in relationship to another quantity. Rates of change can be positive or negative, and a lot of times we use rate of change as a synonym for slope. Slope is really the measure of the steepness of a line or a section of a line, or we're looking at something where there are 2 points involved. So we're looking at how steep that line is. Undefined slope is the slope of a vertical line. We know that we have undefined slope if we are dividing by 0. Zero slope is the slope of a horizontal line. We know we have zero slope if 0 is in the numerator and we have some other number other than 0 in the denominator. And average rate of change is just slope of nonlinear functions, and that is the new piece that we have to work with. So we're just going to make sure we're familiar with slope, and then we'll go into average rate of change. All right, so I can estimate rate of change from a linear graph. That should be something that you already know how to do, but we're going to review. I can calculate slope given 2 points. Again, something that you should know how to do, but we're going to review. I can recognize linear functions go by equal distances over equal intervals. So we're going to look at tables and determine do we have linear functions or nonlinear functions. I can identify the meaning behind the slope and intercepts, but more so the slope of a linear function based on the context of the situation. And I can calculate average rate of change given a graph, a table, or a nonlinear equation. These are our standards. Recognize that linear functions grow by equal differences over equal intervals. Interpret the parameters in a linear function in terms of context, parameters being slope. Interpret slope in a linear model in the context of data. And calculate and interpret the average rate of change of a function presented symbolically, that's with an equation, or as a table over a specified interval, estimate the rate of change from a graph. So we've got all of those built into the standards: equation, table, and graph. All right, so what is slope? So a lot of people will tell me when I offer this question up in class, they'll say y equals mx plus b. No, that is slope-intercept form. That is not slope. Slope is represented by the little lowercase letter m. It represents rise over run, or you can think of it as change in y over change in x. The little triangles mean change. They're little deltas, Greek deltas. But how much are we changing in the y direction over how much are we changing in the x direction? There is a formula for this. If you have 2 points, y2 minus y1 over x2 minus x1, that is how you calculate slope given points. Let's go back to what we learned in Unit 2, where we were looking at our functions increasing, decreasing, constant. As we read our graphs from left to right, we can determine what kind of slope we have. So here we have an increasing function as we read from left to right. So this is a positive slope. So when I write this down, m equals, I should have a positive number, whatever that number is, as my answer. From left to right, it looks like I am decreasing, so that means I have a negative slope. And that would mean that m equals a negative number, whatever that number is. From left to right here, I am staying pretty flat, pretty horizontal. This is a constant function, so I have no change. This is a 0 slope. And when you write this, m equals 0, sometimes people will have like something set up like this. You need to make sure it simplifies all the way down to 0. So don't write that part. And then here, there is no change from left to right. It just is a vertical line, just like the vertical line test. So this is where our slope is undefined. Okay, you cannot write this as 0, oops, not 0, as a number divided by 0, Okay, and just walk away with that. You have to write the word undefined. Don't leave it as a fraction. Okay, all of these you should have no decimals or mixed numbers. I'm looking for improper fractions. I'm looking for simplified fractions. So always, always simplify. All right, so we're going to determine the slope of each graph. Again, pause the video, see if you can figure it out. And then if you unpause the video, see if you're right. Woohoo! All right, so we're looking at rise over run. Remember that? Change in y over change in x. So remember, if I'm going up, it's going to be positive. If I go down, it's negative. If I run to the right, it's positive. If I run to the left, it's negative. So then that way, those sign differences are going to indicate whether you're up, down, left, or right. So I usually start at the bottommost point, and I am going to count up 1, 2, 3. So I have a rise of 3, and then I'm going to count to the right 1. That's a run of 1. So my slope here is 3 over 1, which we're going to simplify to 3. Your job is to simplify these as best you can. All right, let's look at the one on the left, on the right. I don't know my left and rights anymore. All right, we're going to go up 1, 2, 3, 4 until we're in line with that other dot, and then we're going to count to the left. 1, 2, 3, 4, 5, 6. And because it's to the left, it's negative. So I'm looking at a slope of 4, positive 4 over negative 6, which will reduce to a negative 2/3. You have to reduce your slopes. All right, so that is looking at the slope of a graph. Let's look at one like this. Okay, they want to know what the slope is, but they also want to know what the slope means. And what the slope means ties into these values here. Okay, so we have time in minutes, we have water level in centimeters. If you notice that our function is increasing, that would mean that the water level is going up as time goes on. The question is, how much is it going up? So if you notice, it looks like we're counting by tens here on the y-axis, and we're counting by like 2.5s for every other line is counting by 5s. So what we're going to need to do is we're going to have to pay attention to those intervals. We can't just count rise over run and not pay attention to the intervals. So I'm going to start here. I'm going to count by, I guess I can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. So I went up 90. I'm going to go to the right. Okay, that's 5, 10, 15 and a half. That would be 2.5. So that would be plus 17.5. So my slope is 90 over 17 plus 5. But I don't want any decimals in there. So let's pull out the calculator. All right, here's our calculator. And we're going to pull this out, and we're going to look at this 90 over 17.5. So we're going to just divide it. And I know that you can tell me that that is, 5.14 centimeters per minute or whatever. But let's say we wanted to get this as an improper fraction. It makes sense of that. So to do that, you're going to hit math, and you're going to hit enter twice. Math, enter, enter. And you're going to get 36 over 7. And we're going to translate what that means in our situation. So we know that we're doing change in y over change in x. Well, change in y, that's centimeters, and change in x, that's minutes. So we're looking at water level increasing 76 centimeters for every 7 minutes. So the water level rises 36 centimeters every 7 minutes. x. Now, I know if we go back to that 5.14, it would be easier to say 5.14 centimeters per minute. But I already know you know how to do that. I'm trying to get you to go back to a slope that's improper and for you to be able to state what that means based off of the context of that situation and that fraction. All right, let's look at another one. So we've got hours worked. We've got kilograms of dough. We're counting by tens on the y-axis, ones on the x-axis. And I don't have a good point over here. I'm going to use this one. This one's pretty good. 110 and 7, is that 40? I'm going to use those 2 points. Not every point is going to be a great point to use. So I'm going to rise. 1, 2, 3. I'm not rising 3, I'm rising 30, makes a difference. And then I'm going to run 1, 2, 3, 4, 5, 6. I've got plus 6 there. That's a positive 30. So that means my slope is 30 over 6, which is 5 over 1, which is 5, right? But really, that idea of 5 over 1 is really probably something that we want to hang on to for just a minute. Let's look. This is changing y. Y value is about kilograms of dough. And then change in x is hours worked. So it looks like we are preparing 5 kilograms of dough every hour. So I prepared 5 kilograms of dough every hour worked. Not just every hour worked, because that is how it's in the x-axis, how it's given. Right, so you are calculating the slope, but you're also pulling those variables that are defined in for x and y, and you're trying to make it make sense in that context of the situation. All right, we're going to determine the slope of the table. So we're going to look at change in y. So how is y changing? So it looks like I'm adding 12 each time over change in x. Now, a lot of times we just have like 1, 2, 3, 4 up here, but here we don't. We're adding 50 each time. So change in y over change in x, 12 over 50, and we have to reduce that, so 6 over 25. All right, no context in these situations, by the way. All right, change in y, up 1 each time, over change in x, up 0. Okay, so change in y over change in x, 1 over 0, that's undefined. And if you notice, this is not even a function, right? We have 5 being paired up with lots of different y values. So it's not a function because it is a vertical line. Interesting. All right, let's keep going. So calculate the slope and then write a sentence interpreting that slope. Now we're dealing with amount of money earned. Now, because we're dealing with amount of money earned, we're dealing with dollars and cents. Decimals will be okay in this situation. All right, let's try and figure out how y is changing. I got my calculator here. We are adding 4350. We're again adding 4350, but then here we're adding 29. And some people might be like, whoa, something's happening there, but it'll be okay. Just hang on. Here we're adding 8. Here we're adding, oops, that's not 8, that's 6. We're adding 6. We're adding 6. We're adding 4. And that's the reason why the change there. So if I compare, and again, I'm looking here, I'm going to compare these. So slope is 4350 over 6. I get 725, and that's really 725 per hour. But then if I compare here, I'm going to see the same 7.5 per hour. So M equals 29/4, which is 725 per 1 hour worked. So even though I don't experience the same repeated addition each time in both the y and the x, I still have a linear function because those slopes do reduce down. So what does that mean? We make $7.25 per hour worked. Okay. Now, if you wanted to say $29 for every 4 hours worked, you wouldn't be wrong. That would be a good improper fraction to use. It's not going to simplify down any at all. So you could say that. But the 725, the decimal, does make sense in this case because usually we deal with decimals in our paychecks and stuff like that. All right, let's see if we can figure this one out. Changing y over changing x. So here, adding 0.8, 8, 8, 8. Here, adding 0.5 each time. Okay, so my slope is going to be change in y, 0.8, over change in x, 0.5, which is going to be 8/5. So you could look at this as 8 inches every 5 pounds, but you might want to know how much it is for every 1 pound. So 8 divided by 5 is 1.6 inches per pound. That makes sense in the context of this situation. If you wanted to use the 8/5, you could. But really, when you get into this whole, should I use a decimal or not? If there's no context to the situation, this is just x, this is just y. Stick straight with improper fractions. But if the context of the situation makes sense with it, and your decimal is nice, and this one, 1.6 is nice, the other one, 5.14, and it just kept going, that's not very nice. That's not very accurate. So we want to be accurate. All right, so this means the spring will increase 1.6 inches for every pound of weight added. Okay, and you should be able to, from a situation, be able to write a sentence, just one sentence, describing what's going on for that rate of change. All right, let's find the slope of the line between 2 points. The slope of the line is its rate of change. How one quantity changes has an effect on the other quantity. And so we're looking at change in y over change in x, and there is our formula. And we're just going to be given 2 points. So one of the easiest ways I've dealt with this is calling this x1, y1. The 1's mean they come from 1 point, and x2, y2, the 2's mean they come from a second point. Doesn't matter which one's 0.1, which one's 0.2. My formula says y2 minus y1 over x2 minus x1. The most common error that my students have with this is they forget the formula and they put x's on top and y's on bottom. So remember that it's change in y over change in x, y's on top. Y's over 1. All right, so we're going to call y2 negative 1 minus y1 is 2 over x2 is 4 minus x1 is 5. And we're going to just do that subtraction in the numerator. Negative 1 minus 2 is negative 3. 4 minus negative 5 is negative 1. Oops, I was about to write 5 because I said 5. And negative 3 divided by negative 1 is 3. So my slope is 3. Now let's go back to the calculator. I want to show you something that you might find handy, you might want to use. Here we go. We're going to put this in as a fraction. So how do you get a fraction bar? You're going to hit the green button and go to y equals. You see this n/d, that's numerator, and then division bar, denominator, that's your fraction bar. Then we're going to do -1 minus 2, and then hit the down button, 4 minus 5. Now, it's usually pretty good about cleaning things up. So it'll do all the subtraction, it'll do the order of operations for you, and then it should spit out a simplified reduced fraction. So that is something that you can use. All right, let's look at number 10. We've got x1, y1, x2, y2. So make sure you have this formula in your notes so that you can use it. All right, so y2 is 2 minus, 2, that's going to be interesting. -3 minus 0. 2 minus 2 is 0 over -3. And you're going to simplify that down to 0. Do not leave it as 0 divided by -3. Your final answer needs to be a simplified 0. All right, let's look at 11 and 12. So for 11, y2 minus y1 over x2 minus x1. So 1.5 minus 9 over 3 minus -7. 1.5 minus 9 is -7.5. 3 minus -7. Now watch out for this because a lot of people, they get confused with there's a minus and a negative. They just want to do 3 minus 7. And that's not going to work. You have to make sure that you have a minus sign in your equation as well as with your value. And if you remember keep, change, change, you can turn that into a 10 really easy. Now, this is going to be what, -0.75, which reduces, because Ms. Phoebus wants a fraction, to -3/4. But let's feed this into the calculator and see what the calculator will do for us. So alpha y equals, again, if you're not practicing with the calculator, you're not going to know what to do when it does become time for you to use it. So I've got 1.5 minus 9 over 3 minus -7. And then it gives it to you as a decimal, and if you do math enter, it'll change it to a fraction for you. I think the 1.5 in there is causing it to give you a decimal back out as your answer. Most of the time, it gives you a nice simplified fraction. But math enter is your friend. All right, let's look at this one. Y2 minus y1 over x2 minus x1. And over -2 over 0. Uh-oh, we can't divide by 0, so my slope is defined. Let's look at that one in the calculator. And see, we should get an error when we put that into the calculator. I expect an error. So alpha, alpha y equals, that's the better one. And then we're going to do -1 minus 1, 6 minus 6. And then we get a divide by 0 error. So if you plug it in and you get an error from the calculator that you're dividing by 0, it's undefined. The calculator is unable to do it. You're unable to do it, undefined. If you get 0 as an answer, then you're going to just run with 0. All right, clear out everything. Put the calculator away for now. And then we'll get into our average rate of change stuff. Ooh, not yet. Is it linear or nonlinear? Check the slope. Linear has a rate or a rate of change or a slope that's constant. Nonlinear rate of change or slope that is not constant. So let's look. How are we changing? Here we're adding 10, we're adding 2, we're adding 0, we're adding 4. But we're not going to freak out until we compare them with what's going on with the x. Okay? Because you could still possibly have something that is a linear slope. But I'm looking at 10 over 1. Is that equal to 2 over 1? No. Is that equal to 0 over 1? No. Is that equal to 4 over 1? No. So because all of these are nonlinear, and why am I dividing by 1? I'm taking the y and dividing it by its change in x. So this is nonlinear. So we looked at, can you tell from a graph? Can you tell from an equation? Can you tell from that was mostly it. Graph an equation. Can you tell if you have a linear or nonlinear function? And now we're looking at from a table. All right, so let's compare. Adding 3, ooh, looking good. And then I'm adding 1, so if you notice, all of these are the same. It's 3 over 1 equals 3 over 1 equals 3 over 1 equals 3 over 1. Because those are all the same, it's linear. Now, I could have had a different part of this where it equaled 6 over 2. Well, 6 divided by 2 is the same as 3 over 1. So just keep that in mind. They don't always have to be exactly the same writing, but they should reduce down. And because of that 3 over 1 popping up, that's the slope of that line. All right, now we're ready for average rate of change. So what is average rate of change? It is the slope of nonlinear functions. It would be counted like linear slope, but you have to use indicated values. So they're going to tell you where to look and what to use. You cannot just make up your own thing. Average rate of change is just slope. Average rate of change is just slope. Average rate of change is just what? Slope. That's all it is. It's all average rate of change is. For some reason, people get stuck in their head that average rate of change is hard. Average rate of change, AR, average rate of change, is just slope. If you're good with what we've done so far, you're going to still be fine. Average rate of change is just slope. All right, now, they're going to give us our answers written a couple different ways. They could start off saying x equals 4, x equals 9. Pretty straightforward. They could write it in our inequality notation, or I'm sorry, interval notation, where we're starting at 4, we're ending at 9. Or, remember, this is f of x. They're replacing x with a number. These all say the same thing. Start at 4, end at 9. So there's a couple different ways that your indicated values could be written, and you have to be able to read them. But that comes from what we did in Unit 2. There are 3 types: graph, table, and equation. Graph's the easiest. Then next it's the table. Third is the equation. But if you hang on with me to the end, to the last example, I will show you how to make an equation into a table, and then that'll speed up your process a little bit more. All right, so average rate of change. They're going to tell us where to start. They say start at 2. So I start at x value 2, go up and put a point on my function. They tell us where to stop. 4. Now this is a nonlinear function. This is actually one of our exponential function families. Okay, so what we're going to do, I have 2 points on there. It's almost like I'm going to connect them with a line, and I want to know the slope. Now pay attention, what we're counting on the x and the y-axis isn't 1, so we're counting by 2. So I'm going to count rise, 2, 4, 6, and up 6, over run, and ran to the right 2, so my slope is 6 over 2, which is 3. Just like linear functions, but there is a different piece. They have a start and an end. They have to give you that. They won't ask you an average rate of change problem without giving you that. But notice that the slope between those 2 lines is different than the slope between, or 2 points, between those 2 points, which is different than the slope between these 2 points, okay? So they have to give you values where you start and where you end. All right, so here they're telling you to start at x equals -4 and to stop at x equals 10. So x equals -4 is right here on my function. X equals, I think I said 10. I said that wrong, that's 0. If I was to connect these 2 points with a straight line, do you see how it's negative? My answer should be a negative slope. So I'm going to count rise, 1, 2, 3. I did an up 3. I'm going to count a run and count to the left, 1, 2, 3, 4. So that's a -4. So my slope, my average rate of change, is -3/4. Average rate of change is just slope. Average rate of change is just slope. average rate of change is just slope. All right, so that was a graph. Now let's look at the table. Now, they will give you two values. They're giving you two x values. You go where those two x values are. So x is -2 right there. X is 2 right there. The rest of the table we don't care about. We ignore the rest of the table. Who cares? I don't care. You don't care. All we care about are those 2 points. Okay, now I highly recommend not scribbling everything out because you might have to use that table later, but this is the idea that I'm trying to get across to you. You don't need the rest of the table right this moment. You can do y2 minus y1 over x2 minus x1. You can say we'll go from -12 to 4. I add 16. Add 16. Get out there. To go from -2 to 2, I'm going to add 4. 16 over 4 is 4. That's my slope. That's my average rate of change. Average rate of change is just slope. It's like subliminal messaging. Average rate of change is just slope. All right, here they're telling you to start at x equals 3 and to stop at x equals 11. They always give you the x values. Get rid of everything else. We don't care about you guys. We don't care about you guys. 3 and 18 are the only ones that survive, and we want to look at their change in y, up 3, or change in x, plus 15. So we're looking at 3 over 15, which can reduce to 1/5. That is your slope. That is your average rate of change. So graphs are the easiest. Then the tables are the next easiest, and then the hard ones are the equations. But I've got a shortcut for you if you stick around with me. All right, again, they're giving you x values. So x equals 1, x equals 5. They're going to tell you to plug those in. So what we're going to do is we're going to plug in, notice there's a negative there, we're going to plug in 1. We're going to go through the order of operations. So 1 squared is 1, 1 times -1 is -1, -1 plus 4 is 3. So I have a point 1, 3. A lot of people try to write 1, 5 as a point, but you have to have 2 points to do slope. All right, -5 squared plus 4. 5 squared is 25, so this is -25 plus 4, which is -21. So 5, -21. And then we're going to do slope. Okay, a lot of times people stop here and they're like, woo, we're done. And that's where I'm saying that equations are a little bit tougher, because you have to go through all that work to get the y values. For the graph, the y value is there. For the table, the y value is there. For this one, you have to find the y value and then do slope. So slope is -21 minus 3 over 5 minus 1, which is -24 over 4, which is the slope of -6. Average rate of change is just slope. Okay, so that is, there's 2 stages to this. There's plug in the x, get a y, plug in the x, get a y. You're not done there, because then you still have to do slope. But let me show you a shortcut. And watch out, because some people, they just do the y's subtracted and not do the x's subtracted. So that is an issue too. So let's say you wanted to find a shortcut. I'll give you a shortcut. We're going to go y equals, we're going to type in our function, 3x squared minus 3. Okay, and we're going to hit second table, or second graph, and we're going to go and we're going to pull these values from the table. So -3, comma, looks like 24, and then +3, comma, 24. So I used the graphing calculator to help me figure out what the y values were, and that is a shortcut that you are allowed to do. All right, y2 minus y1, 24 minus 24, which is interesting, over -3 minus 3, and 0 over -6. My slope, my average rate of change is 0. All right, so you can use a graphing calculator to help you out to pull those y values from the table. I think that makes the problem a whole lot easier. But you do have to use the ones that they give you. I used -3 because they told me to use -3 is the x. I use positive 3 because they told me to use positive 3 as the x. They're not giving me an x and a y. They're giving me two x's. All right, so average rate of change is just slope. See you in the next video.